welcome to one of my most favorite chapters in all of Algebra 1, dealing with exponents. And so throughout the chapter, we're going to be seeing different rules and different situations that you're going to experience with exponents, look at patterns, and then develop the rule on how to deal with those kinds of exponents. So today we're focusing specifically on zero and negative exponents. Our target is that we will simplify and evaluate expressions with zero and negative exponents. Simplify, meaning that you're shrinking it down as much as it can be. Evaluating, meaning you have all the numbers needed and you can get a final numerical answer. So let's look to see what you already know about exponents. So you're used to something like this. 2 to the 4th would be represented like expanded out as 2 times 2 times 2 times 2 times 2. That you have 4 2's being multiplied together, which equals 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, so if you go down an exponent, you have 3 2's. 2 times 2 is 4, 4 times 2 is 8. If you have 2 2's, 2 squared, you have 2 times 2 is 4. If you have 2 to the first power, you have that is 2. And so what we're wondering here is, what is the pattern that you see going on? So as your exponent is going down by 1, right? 4 minus 1 is 3, 3 minus 1 is 2, 2 minus 1 is 1. And as our exponents go down by 1, that power is being divided by 2. 8 divided by 4, 8 divided by 2 is 4. And then if I divide 4 by 2, I get 2. So if I were to continue this to the 0 power, that pattern still continues. So what is 2 divided by 2? It's 1. Okay, so let's continue that again. If I divide 1 by 2, I would get 1/2. Okay, so let's continue again. If I divide by 2, 1/2 divided by 2 would be 1/4. If I were to continue that again, I'm going to have 1/8. So the pattern that you ought to be seeing is that the 0 power is equal to 1. You might think that since it's a 0 power, it will be 0, but it is 1. If you don't trust me, try it in a calculator. Put 2 to the 0 power, or put 4 to the 0 power, or 5 to the 0 power, and see what you come up with. You're going to see that every time it is equal to 1. Now when you have negative exponents, you're dividing that power by 2 to go down by 1 in each of your exponents. And so what's happening is you have a numerator of 1 every time, but the denominator is that base to the positive power. 2 squared is 4. 2 to the third power is 8. So let's kind of sum that up of what we see. First, any number to the 0 power equals 1. It could be 5 to the 0 power, it's 1. Negative 3 to the 0 power, it's 1. W to the 0 power, it doesn't matter what W is, it's going to equal 1. Negative 4.333333 to the 0 power, it's 1. If I have 2 variables to the 0 power, it's 1. It doesn't matter what the base is. If the exponent is 0, it's equal to 1. So write that real big in your notes because that is a big deal. So that takes care of this one that we were trying to figure out. Now let's look at these negative exponents, and let's kind of sum up what happens there. As you saw, that negative didn't make the power negative. That negative was dealing with the exponent. So 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. But it shifted those numbers to the denominator. It shifted it so that it's reciprocal. So if I had W to the negative third power, that can be rewritten as 1 over W to the third power. Basically, that negative shoves the power, W to the third, down to the denominator. Or if it's the other way around, if I had 1 over X to the negative second power, that can be written as a positive X squared, because that negative moves it up to the numerator. So here's something to think about. The negative exponent has nothing to do with being less than 0. It's not a negative in that sense. It's all about it becomes the reciprocal of that power. So these two things would be equivalent. w to the negative third over 1 is equal to 1 over w to the third. See how it's the reciprocal of it? And likewise, 1 over x to the negative second power is equal to x squared over 1. It's the reciprocal of it. That's what you do with a negative exponent. So summing up, numbers to the 0 power equal 1. Negative exponents move that power to its reciprocal position. So let's practice a little bit. X to the negative 9th power, what that negative says is that x to the 9th power needs to be on the bottom. So that would be equal to 1 over x to the 9th power. This one down here, 1 over n to the negative third, that says that n to the negative third, n to the third is going to be moved up here. The negative disappears because I'm putting it up there as the reciprocal. So that would be over 1, which simplified is n to the third power. Okay, now for this one, 4c to the negative third power b. Part of this chapter is being able to recognize what base that exponent is being applied to. Let me get a highlighter here. Okay, so this c to the negative third, that negative third is only being applied to c, so I'm going to push that down to the bottom. If you want to keep a highlighter at your desk like I just did and highlight what base that exponent is being applied to, that is completely fine. So that c to the negative third, that's going to be pushed down as c to the third. 4 and b, nothing happened to that, so it is staying up in the numerator. So 4b stays on top and c to the third goes to the bottom. On this last one here, n to the negative fifth and n to the negative fifth and over m squared, the n to the negative fifth power, that's going to be pushed down. So as you see, there's nothing left on top, so for my simplified version, I have a 1 on top, and then I will have m squared and n to the fifth on bottom. So for evaluating exponential expressions, there's going to be a couple of ways that you can do this. You can either simplify that first, like push n to the fourth down to the bottom, or you can substitute first, either way. So I'm going to show you both methods, and there's not one method that is superior to the other. It's really just, a matter of personal preference. So if you were to simplify first, like I'm simplifying, ignoring that n equals negative 2 and w equals 5. That n to the negative fourth power is going to be pushed down to the bottom, and w to the 0 power is equal to 1. So this part is going to be going down, and this part is going to be equal to 1. So what that means is I have a 1 left on top, and n to the fourth is on bottom. So I have it simplified, then I'm going to substitute. The w to the 0 power, it didn't matter what w was because it was going to be equal to 1. The n to the fourth power is negative 2. So that's going to be 1 over negative 2 to the fourth power. Notice how I have negative 2 in parentheses. If you're going to plug this into a calculator, that is extremely important that you have the parentheses. Without the parentheses, that is 2 to the fourth power and whatever that is, negative. Whereas here, that's negative 2 times negative 2 times negative 2 times negative 2. So, negative 2 times negative 2 would be 4. 4 times negative 2 would be negative 8. Negative 8 times negative 2 would be positive 16. So this is going to equal 1 over 16. Now the other way that you could do this would be to substitute first. So if I did that, I would have negative 2 to the negative fourth power times 5 to the 0 power. Then going from there to simplify, that means that the negative fourth power is only being applied to negative 2. So it would be pushed down. So I would have negative 2 to the fourth power on bottom. And what's left on top is 5 to the 0 power, which is equal to 1. So you see how that takes me back to what I had here? I'm still getting to the same ending of 1 over 16. So either way, it doesn't matter, just personal preference of which one you do first.